Swayam Prabha. Digital India. Educated India.
So, good morning friends. So, we will move to the next lecture. The next lecture is on pultrusion. So, pultrusion is a process. If you see the name itself, something might strike you, pull. So, there has to be something like a pulling component and trusion. So, this trusion comes from extrusion. So, we are going to learn a process wherein which we are trying to see pulling plus extrusion put together for making a composite. You are right. So, like in filament winding process, there is a fiber which gets immersed inside a tank where there is a resin, it immerses and then it gets out of the tank with coating of resin on top of it, and then it is wound on a mandrel. So, in the similar way here, we have to make sure that the fiber or the reinforcement is uniformly wetted with resin, and then we try to extrude it through a die. So, the process name very clearly says it is pultrusion, pulling plus extrusion. So, that is what is the process we will see today. So, now quickly what comes and strikes to your mind, what will be the, can I make different shapes? Yes, you can make different shapes, but it has to be in a restricted die. So, for example, you can make a cross section, uniform cross section materials or products you can make through pultrusion. So, the content is first we will see the introduction of pultrusion, then the process setup, then pultrusion, what are the different kinds of reinforcement, then matrices, here it is thermoset. So, what are the different matrices in thermoset, then consolidation, how does it happen, advantage, disadvantage and few of the applications. It is a low cost process. By and large, composites itself is used for batch production and small volume production as compared to that of polymers, right. So, here whenever I talk about small volume production, the cost comes into effect. So, it is a low cost process and it is also used for high volume. High volume, please do not compare the high volume with respect of a polymer or with respect to a metal forming operation, sheet or a rod or shaft, something like that. This high volume is comparatively in the spectrum of composites, it is a high volume process. Here the resin is impregnated on a fiber and it is pulled through a die. Now, it is very clear the die geometry is the part geometry. So, if there is a die, so it has to be predominantly axis symmetry part. So, it is used for making axis symmetry parts. So, it is like your extrusion process what we use in metal forming, the metal is extruded through a die to give a shape. So, same way here the fiber along with the resin is extruded through a die which gives you the shape. The process is very similar to that of your metal extrusion process. The only difference is instead of a metal, here you will push through the you will pull the fiber and the reinforcement through the die. So, it is pull, there it is push, right. So, this is what is the difference. So, the pultrusion creates a constant cross section and continuous length. So, this is the gist of the process. So, the gist of the process is you will pull the component out of a die. So, the cross section will be uniform and it can be a long lengthy parts. For example, if you want to make a cover, a strip cover or a shaft you want to make made out of thermoset resin with fiber reinforcement, you can do it through this. So, pultrusion process, it is like this. So, here you see the rovings. So, you can have a combination of glass fiber, carbon fiber, Kevlar, whatever combination you want, you can start putting it here, and correspondingly all these things are continuous strand mats, it is all here. So, then it gets guided, then it gets into a resin bath. In this resin bath, the glass fiber is wetted and now it is further passed through. After it is wetted, then it is surfacing wheel happens and then it tries to get into a die, which is where it tries to get into a shape, a forming and curing is happening as and when it passes through it. Moment it is getting a shape and it is slowly getting cured. So, here what happens, there has to be somebody to pull it out. You can push it or you can pull it. So, pulling is easier. So, we try to pull the glass fiber along with the resin outside and then it is continuously allowed to cure. You will have rollers continuously for long lengths and depending upon the length they cut it off. So, this is a cut off saw which tries to cut to your required dimensions. So, here the die geometry can be circular, it can be rectangular, it can be square, it can be hexagon, and all these things can be for this is shape classification, and then you can also have another classification whether to have a solid or a hollow tube, that is also possible. So, you can have a pipe or a shaft of varying cross section area. So, here it is a pultrusion process, a continuous roving. Again this roving can be a combination, can be glass fiber, can be Kevlar fiber. So, you can choose, or it can be a mat, it can be a roving or it can be a mat which is pulled through the resin bath. So, this resin bath will try to have a thermoset which can be as usual 3, which can be epoxy which is easy to work. You can have polyester to work or you can have some ester or you can also have nylon, not nylon, you can have polyester and you can have some other polyester also. You can have another epoxy also. So, if you see in this, so it passes through a resin bath and then it is pushed into a preformed fixture, and it is not that just it exits, you take the preform for a longer distance. So, where the cross section is partially shaped and the excess resin and air gaps is removed and then you allow it to cure. The impregnated fiber then passes through a heated die where the cross section is cured. Is it clear? So, here the section is partially shaped and the excess resin is removed. As and when it is removed, the air is also, the air which is trapped is also removed, and then you move to the next stage where the die is heated and then you get the required output. So, in pultrusion process basically consists of the following elements. One is reel and the resin bath, preforming fixtures, matched metal die for the extrusion, then it is puller which tries to pull, and then cutting saw. Cut off saw is the it measures a required distance and then it tries to make. So, resin bath where you have the resin. Here when I talk about the resin, you will have a mixture resin, hardener and you can have whatever it is, catalyst. You can also have other impregnations, whatever you want to do, you can also have. For example, you can even you can also have a filler if you want, impregnations or fillers you can add. So, preforming fixture, this is what is the preforming fixture, forming and curling. So, this is what is a preforming fixture, matched metal die where there is a heating arrangement, because as and when the fiber flows into the die and the forming fixture, so there will be slightly heat applied because the resin should not set. So, they apply heat and the resin also they try to play a little bit with the viscosity. So, this is what it is. So, this is the reel. A reel is a continuous roving consisting of a books casing type shelves with ceramic eyes located at a convenient interval to lead the roving into the resin bath. Basically, this is a place where you stack all the glass fibers. It can be fiber or it can be a mat, roving or it can be a mat. So, then this is the resin bath. Interestingly, resin bath, you look at it, it is never a deep trench like this. It is a gradual coming in and a gradual exit out. So, this is what is followed. So, this is what is given here also. The resin bath is generally made out of steel or aluminum trough containing rolls the force of reinforcement to pass through the resin and completely wet. So, the entire wetting process happens only in the resin bath. So, you can have multiple stage roller going up and down you can have, such that you doubly make sure the stiffness is maintained, the wettability completely happens. If one fiber in the roving is not getting wetted properly, then it might lead to a defect. Most of the wet out tanks contain a set of rollers or slots that exits to remove the excess resin from the reinforcement. So, moment it comes out, you will have two rollers. These two rollers will squeeze and try to remove the excess resin. A comb or a grit plate is provided at the entrance and exit of the reinforcement. A grit plate is given here. This is a comb or a grit plate. So, it makes sure that the glass fibers passes through this grit plate and then comes into the resin bath. This is basically to maintain tension, basically to avoid interlocking and other things. This is a preforming fixture. You can have a very close look of it. It tries in consolidating the reinforcement closer to the shape. You do not get the final shape in one shot. So, the preforming fixture tries to play an important role, try to consolidate. What is a consolidation? Consolidation between resin, reinforcement. Between these fellows, this does it, and then you try to get a required shape. They may with fluorocarbon or ultra high molecular weight polyethylene. So, this is the material which is used in this fixture, so that it can help in cleaning and doing. So, for longer life and higher production, chrome plated steels are also used. So, this is how it is. You can see here the fibers coming in and the resin bath and then the fibers. These are the fibers which goes out of it. So, you can have a chrome plated one or a polymer one. So, Pultrusion process, here the matched metal die and the heating arrangement is given here. So, here we have to apply heat. So, heat is generally applied nowadays by RF. You can apply heat by induction heating, that is means to say you can put a coil. People are also using infrared heating. People are trying to play with it so that you can get a better efficiency. So, the metal die is heated with electric cartridge and strips of heaters, or it is oil heat. Hot oil is not thought of nowadays, because nowadays the electric things are found to be much more efficient. Handling hot oil has its own problems. The conductivity of the conductive heat passes through the die walls and helps to a high level and makes sure the curing happens. And here interestingly what is that is we are trying to work on thin sections also. So, in thin sections, if the heat is not properly applied, it always tries to warp. So, that is one thing. So, curing of thick sections also needs to be done in a very quick fashion. So, we go for radio frequency or infrared. So, the use of is in conjunction with the conventional increase of productivity and permits for a massive profiling. So, this is the Pultrusion mechanism. You see here there is this is a roller, and here it is not a roller, it is something like an endless belt which keeps rotating, and here this tries to roll and it tries to pull in. So, puller or a driving mechanism. The puller can be either a pair of continuous caterpillar belts containing pads that engage in pultrusion, or a pair of cylinders with pad pullers. So, these are pad pullers. So, what as and when it rolls there, if the glass fiber is coming, if the roving is coming through this direction, it will try to maintain a tension and it will try to pull it and then go. This is a saw. So, this saw can be two types. It can be mechanical type. You can have a saw to cut, or you can use heat to cut. So, heat to cut, again it can be laser you can use for cutting, or you can even apply induction heating. But induction heating, the only one thing you should understand is the cutting of fiber becomes a challenge. So, we always prefer this or we prefer this. In this also what happens is if this is the object, so if this will be the protrusion of fiber, these are fiber protrusions. If we do not have a proper shearing mechanism, we will have these protrusions which are coming out, which will appear. So, today laser is used exhaustively, which can very easily go cut it. So, it is a conventional cutting saw, wheels are used. So, we use coolant, but we should keep in mind, moment we have a matrix and we have fibers, these are fibers, and if there is any small amount of cracks or defects or delamination is there, moment you spray coolant which is water based, then what happened, there is a hygroscopic effect. Then forming follows impregnation. So here the forming guides attached in the front of the pultrusion die, the ensures positive alignment is very important of the form material. The sizing of the forming guide slots, holes, clearance must be designed to prevent excess tension or relative weak points. Then forming guide materials includes Teflon, all these things. They requires experienced craftsmen for designing and fabrication a forming guide. Hollow parts uses mandrel in between. So, that means to say you will have a die, you will have, this will be the mandrel. This will be the mandrel and the fiber flows through this out. So, this is a die, outer surface. So, alternative methods for impregnating and forming method is inject resin directly into the die after dry material is formed, eliminate problem associated with dip bath, the limitations, it satisfactory wet out, air trapment is less, and then maximum fiber content can be done, and the environmental concern also can be taken care with the dip. So, pultrusion reinforcement, it can be a E-glass fiber, S-glass fiber, carbon fiber or Kevlar fiber. The form of the resin can be roving, can be a matte, can be a fabric also. So, fabric is a fabric whichever is there, it will be rolled, and then you will try to give the resin impregnation. So, the matrix used polyester, vinyl ester and epoxy, these are the common resins used, but the most common among the lot is epoxy. Epoxy is a very slow process, then the reaction rate is very slow, it has a shorter pot life, but since it is liquid starting form and there is a huge strength, people always go for epoxy. Polyester controls with the styrene level is critical, shrinkage upon the curing, facilitating release from the die is also there. Epoxy is the most commonly used matrix for making this pultrusion process. So, consolidation and curing, the positioning and anchoring of the die is very important, must transfer thrust that develops as material is pulled through the die to the frame without allowing movement of the die or deflection from the frame. So, this is very important. I repeat, must transfer thrust that develops as material is pulled through die to the frame without allowing movement of die or deflection of the frame. Basically, what we are trying to say is, without making the die move even a few die to get deflected, we are trying to position and anchor the die. So, the die has to be very tightly and very properly positioned. Then the source of cooling is also done and the source of heating the die is also done. This cooling and heating follows the same thing of your injection molding process. There are curing methods, there can be a die curing, that can be tunnel woven method, there can be split die method. Die curing is at multiple zones in the die itself, we try to cure it. So, here starting at low temperature and the increases across the zones, and then we try to increase, easy to control and achieve in a steady state. When you talk about tunnel woven method, the pultrusion is gelled in die and fully cured during the travel through the oven. So, it is nothing but like a pizza, whatever happens, you pass through a heating pan. So, in the same way here, pultrusion, the tunneling oven. So, the oven which is used for even in pizza. So, we have a oven. So, in the same way, what is that oven does? Oven has two things, one is temperature, another one is time. So, as and when it moves, the component moves, it takes certain time. So, you control the time period here and also you try to control the temperature. So, time and temperature is controlled. The time in turn is controlled by distance. So, that is why you see in pizza, you will always have a oven which is which runs along a length and it will be an endless conveyor belt which keeps rolling. The same way we can do here. So, the pultrusion is gelled in die and fully cured during travel through the oven. The length of the oven determined by line speed, part dimensions and the curing characteristics of the resin. You can also have something called as a split die method. The split die mold half brought up against the pultrusion as it exceeds the die. So, this is another thing which is also possible. The process parameters which are involved, the most critical parameters is the rate of, determines the rate of reaction, the position of reaction within the die, that is very important, magnitude of the peak exotherm, because as and when it is curing there will be a heat release. Improper cured pultrusion will exhibit poor physical and mechanical properties which visually might look okay, but when put on service condition might fail early. Clamping and pulling. So, the clamping can be here, the pulling can be intermediate pulling, which is reciprocating clamp, continuous pulling, reciprocating clamp, continuous belt puller is also there. So, here there is a single clamp, the clamp pulls through a pulls and get released, enters, and then it also has intervals. During the return interval, pultrusion remains stationary until the clamping and pulling cycle can be reinitiated. So, these are basically different types of pulling techniques which are used in the shop floor to produce a good quality output. Continuous pull reciprocating clamp, here the release return cycle is synchronized between the pullers to provide a continuous pulling. So, that is what we said. If you go back and see here this diagram, here I said this is what is the two things which are getting pulled in a regular with a proper tension, and so that you get a good output. So, these are some of the components you can see. So, you can see here a solid, you can see here hollow, and interestingly you can also make eye sections through this pultrusion process, which is very wonderful. So, all these things are nowadays used for structural applications. So, structural application means this can be a load carrying member, it can be a load carrying member, structural applications can be done. So, usually they are grouped into two, one is solid rods and bar stocks. The other thing is you can also make structural profiles out of this. So, you can make structural profiles. So, you can extrude, whatever can be done by extrusion process can also be done, but the only difference between that is here you will have matrix and fiber. So, there it will be only matrix. So, here it can go for high strength, and it looks here what is that these things can be on top of the polymer, you can also give a metal touch. So, then it looks like as though it is a metal aluminum channel, but it is made out of composites pultrusion process and you get the output. So, this can be made, this can be made, and these stocks can be made. So, section of the pultrusion part not strictly based on the price competitiveness, but the other characteristics not found in the traditional can be done. So, if you want to make a non-conductive ladder rail, so it can be done. You can have an application in electrical utility industries, we can have insulators made out of it, hotline maintenance tools can be made, booms for the electrical bucket trucks can be made, gratings can be made like walkway, staircase, etc. So, these things are nowadays made out of pultrusion process. So, we have already seen these examples. So, it can, and all these things also we have seen. So, wherever you would like to have continuous production process, so there we would try to have this pultrusion process. So, it advantage, it has a very high throughput, because if you initially set the process, then if you have a constant dry, you keep on pulling. So, here the products can run to several meters. So, the lines are reporting certain profile to 10 to 15 feet per minute for a typical line speed of 2 to 4 feet per minute. So, those of who do not have a feel for a feet is nothing but 30 centimeter is 1 feet. So, it has a high material usage. So, there is high material usage, that means to say there is less amount of scrap which is getting produced, and whatever you produce here is final product. There is no other secondary process done on it. So, you can do it on a variety of reinforcement type depending upon the form, style, thermoset, everything. Then commonly thin walled shapes can be fabricated, can fabricate extremely large parts, can fabricate any transportation length part also, transportable length parts also can be made out of this pultrusion process. So, the shrinkages commonly is only 2 to 3%, the straightness along the length, the lateral and bowing to a large extent can be controlled because of the reinforcement present. So, this can be taken for heavy things. The quick cure resin system typically has lower mechanical properties. So, you have to have a trade off between the between curing time and strength. Okay. So, the complexity of the processes, resin, fiber, so we have to make sure the wettability comes, and the dye entry point is one more thing, and then the parts of the run resin rich content account for the fiber. So, it is like agglomerations, anomalies, strength on the synth is done. So, here assignment part of pultrusion, what I would like to do is try to fabricate a dye which can be made out of plaster of Paris, or you can take clay, you make a dye, okay, and through this dye you try to push, say for example, you have, this is a dye, so you have made some cross section, whatever it is, star or right, and then what you do is through this dye you try to push a dough which is made out of wheat. Okay. So, this dough, what you do is you change the viscosity of the dough. How? You keep changing the water content and you keep pressing it, right. After you do, you get an exit out. So, whatever exit you get, so then what you do is you try to make a table. So, what you do, serial number 1. So, what is the water content? And then what you do is you try to measure, you try to have a strength feel, and you also try to see the shrinkage. Okay. So, one more column you can open with respect to time. So, serial number 1, water content, whatever, say for example 10%. So, strength again you can take it in terms of qualitative, you can say less or more, whatever it is, shrinkage again less or more you can see, and then time you can say after 10 minutes, 20 minutes, 30 minutes what happens to the same component. So, with this what will you try to have is you will try to have something, an experience with respect to viscosity, what will be the pressure applied, and with water content what happens to shrinkage, and then you will try to see what is the performance of the product in terms of understanding. So, with this we will try to complete. So, in this lecture what we saw was pultrusion process. Pultrusion is nothing but pulling plus extrusion of a glass fiber which is immersed, which passes through a resin and gets coated. Thank you very much.